So hello friends, welcome back to our channel STMetaTronics. In this video, we will see how to interface the Bluetooth. Okay, the Bluetooth HC05 module. So this module, I have taken this module from engineeringprojects.com. Okay, this module is very simple to install. So if you go into here and type HC05, right, you may get a ton of ICs. Once you type Bluetooth, right, you will get this two module, HC05 and HC06. Okay, it is very simple to install. Like, you have to download the files. Okay, once you have downloaded these two files, right, extract the files. You will see that there is a .lib and .idx file. So go inside your PC, then go into your users, the program files, lab center electronics, professional, then licenses, sorry, library, and here you have to paste the .lib file. Okay, then once you go one folder up, somewhere here you have to paste that idx file. So yes, inside this library indexing, here you have to paste this idx file. Okay, so once you do that, this SC05 module will be available inside the Proteus. Okay, now we will see that our this project is working properly. So in this project, we will see is the communication between two Bluetooth devices. Okay, here we will send some data from HC01. We will send some data on HC02. We will receive some data, and that data we will be directly printing on the UART. Okay, whatever data we are entering through UART, it will be sent through this HC02 module, and it will be received at HC01. Then this module will receive the data. Okay, depending on the data that we have entered, okay, this controller will take some action. Okay, now what action it will take? It will basically turn on these three output devices, either output devices, or we can say this optocoupler, whatever device we are connected to the optocoupler output. Okay, so for demonstration, we have connected LEDs at the output of the optocoupler. Okay, and it is fairly simple. Okay, so whenever we are pressing one of these three buttons, certain character will be sent through the HC01. Okay, this Bluetooth module, and it will be received at this second Bluetooth module. Okay, then this Bluetooth module, whatever we have sent through this first Bluetooth module, it will be received at second Bluetooth module and will be displayed over the UART. That's a fairly simple project. So whatever, this is fairly simple circuit, and we have already seen in our previous project. Okay, previous menu project, so you can take a reference from it. So in that project, what I have did is I have directly connected this UART serial terminal to the PA9 and PA10. PA9 is TX from the controller, so it should be connected to the RX of the Bluetooth module, and PA10 is the RX of the controller, so TX of this Bluetooth module is connected to the RX PA10. Okay, now see, we will start. So it is fairly simple. We have transmitted STMetaTronics whenever we are restarting the controller or we are restarting our program. So that is received on the second Bluetooth module, and it is displayed over the UART. Okay, now when I press first button, see, character A is sent. When I press second button, character B is sent. When I press third button, character C is sent. Okay, if I press this button continuously, character C will be transmitted continuously. Okay, now see from here, so this is A, B, C characters are have been sent. Okay, so if I enter X, so in the virtual terminal, if I enter X, okay, capital X, so you can see that first LED is turned on, character Y and character Z. So X is for this, Y is for this, and Z is for this. X, Y and Z. Okay, so likewise, now what we will do is we will again enter X, Y, and we will again enter Z. Now if you can see that this LED is continuously blinking, that means there is a error in our program. Okay, we have not cleared what we have what we are receiving through the UART terminal. Okay, so here we are not cleared. Okay, so yes, that's a fairly simple project. Now we will see how it's made. Okay, so I have shown you how to import the Bluetooth module, how to add the Bluetooth module library in our Proteus project. Okay, now coming to the IDE, ST32 CubeIDE, STM32 CubeIDE. Okay, so once you go to this, click on File, click on New, click on STM32 project. Okay, now here enter STM32 F103C8. Now select T6 and select LQFP 48 package. Click on Next. Okay, give here name, project name, that is Bluetooth communication through STM32 F103C8. Okay, now click on Next and click on Finish. I have already created my project, so I am not going to click on the finish part of it. Okay, now coming to the configuration, pin configuration. Okay, so for this project, what we will be needing is 3 input and 3 output. Okay, PA0, 1 and 2 are connected as input, so we'll configure PA0, PA1 and PA2 as GPIO input. So click on this pin, GPIO input. Okay, likewise PA1 and PA2. Now 3 output pins are PA4, PA5 and PA6. We have not connected PA3. Okay, PA4, PA5 and PA6. Click on pin and click on GPIO output. Okay, along with that, what we will be needing is to communicate with the Bluetooth module, we will be needing a serial port, right? So fairly simple. If you go to this HC05 Bluetooth module, right, in the description you can see that the Bluetooth module default baud rate is of 9600. We can obviously change the baud rate, but there are some AT commands involved in that. Okay, so this Bluetooth module is fairly simple to interact with, to interface with. We need only the serial port, one serial port, that's all we need. Okay, so you can see that HC05 is a wireless serial Bluetooth module for Bluetooth module to interface with any microcontroller. It uses UART protocol to make it easy to send and receive the data wirelessly. So obviously we will be needing a UART port. So now to configure the UART port, what we have to do is go to the connectivity section, click on UART, keep the mode as asynchronous, right? Now come down to this section, set the baud rate to 96000 because the default baud rate is configured as 9600. If you want to change that baud rate, there are some different commands. We will be seeing those commands in the next video. Okay, then you don't have to configure anything, rest you leave it as it is. Go to system core, go to GPIO, right? Now we have 3 input ports and 3 output ports, right? So here you can go to output push pull, right? no pull up, nothing. I have left it as it is, but if you need, you can connect it as internal pull up, internal pull up, internal pull up. Okay, keep the speed to medium. Keep the speed to medium. Okay, if you need, you can internal pull up or pull down, you can connect, but for our project we have connected external. So internal pull up, I'll connect internal pull up, internal pull up. Okay, or internal pull down, internal pull down, internal pull down. Okay, so I have configured these 3 input pins with internal pull down resistor. Okay, and 3 output pins with internal pull up resistors. Now click on generate device configuration, generate. The clock configuration I have kept it as HSC. So basically I have not tampered with the clock configuration. If you want, you can go over here. So we are using the internal RC oscillator that is of 8 megahertz. Okay, and that we are using for the system clock, directly for the system clock. So I have not changed that. Okay, so now coming to our program. Before here, you can double click on the controller. You can keep the oscillator frequency to 8 megahertz and oscillator 32 frequency to 8 megahertz. These 2 settings you can do. Okay. Now coming to device configuring power rails, ground. So there are VSS and ground power rails. In the VCC power rails, VCC and VDD, the voltage is of 5 volt, and VE it is minus 5 volt. So you can configure it to 0 volts and click on OK. Okay. Now coming to the main program. So the main program is fairly easy. Okay, we have not added any global variables starting from the main file. Now coming to the main loop, coming to int main. So see, as you have seen in the program, that is we are displaying the STMetaTronics, our channel name, and we are sending it through the Bluetooth, right? Bluetooth module 1 over Bluetooth module 2. So that is the first thing that we are doing. So to do that, we will be needing the character array, right? Our channel name character array. So we have done like this. uint8 character is also of 1 byte. uint8 is also of 1 byte. So uint8 character array, and we have given our channel name. You can configure whatever name you want over here. Okay. Now coming over here, array size uint16, then size of character array. Now we, like, whenever we are pressing the buttons, right, we want to send certain characters. So these characters are configured over here. Okay, described over here. So character Arduino or Arduino TX code 1, TX code 2 and TX code 3. So A, B and C, right? Similarly, whenever we are receiving the 3 characters from the Bluetooth module, we want to turn on the output of output, right? So depending on the 3 characters, so those 3 characters are defined, will be defined over here. Okay. Now code receive, we want to receive the character over the serial port, so that's why we will be needing an extra variable, and we have kept the 3 characters basically. Okay, command characters 3. Now coming over here, these are the system initialization. You don't have to do anything over here. Now in the user code begin to section, right, we are sending hard transmit character array. So that's the first thing that we are doing. Then we have given the delay of 1000, that is 1 second. 1000 millisecond, that is 1 second. Now coming to the continuous while loop, right? So we are first, what we are doing is we are reading the pin, GPIO pin, GPIO A pin 0. If it is equals to 1, that then that is this is what, if the button is pressed, right, if the button is pressed, it will be connected to the VCC. That's why we have connected the internal pull down. So whenever button is released, it will be connected to ground. Okay, but when the button is pressed, it will be directly connected to the VCC. Okay, so that's why we have written the logic like, if the GPIO pin is connected to VCC, that is logic 1, then transmit first character. Okay, and then we have transmitted \r \n, that is return carriage and new line. Okay, these two characters. If now coming to second button check. Okay, so we will come over here, we will check the second button is pressed or not, right? So GPIO pin 1 is connected to 1 or not. If it is yes, then we will be sending second character. Similarly for GPIO pin 2, that is for the third button. Okay, now we will receive the character. We will check for whether if any new character is received or not, right? So we will receive a new character. We will check for receiving the new character. So HAL UART receive the character in this variable code receive. We want to receive only 1 byte. Okay, and the timeout for receiving is of 1000 milliseconds, that is of 1 second. So if you don't receive the any character within 1 second, then it will come out of this loop. Okay, and it will execute the next loop. So that delay we can also reduce. We can make it of 500 milliseconds also, or we can keep as long as we want to wait, right? Then code receive. So if this received character is matching with the Arduino RX code, that is this X, right? So what we are doing is GPIO toggle pin, right? We are toggling this output state, LED state, right? We are making it on and off. So that's fairly simple. If not, now here we have used the else if. So if this received code block is not equals to X, then it will come to check over here. If it is equals to Y, that is second code, RX code, okay, then it will toggle the second output pin. If not, it will come to check that else if it is equals to Z, right, it will toggle the third output pin. If not, it will come out of this loop. Okay, and it again it will come to the main loop. So with this 500 millisecond delay, it will again come to this inner loop. Okay, now see, if the code received is equals to X, it will come and it will toggle the state of the output pin, right? After that, we have flushed this character, right? Received character, whatever received character we had, we have flushed it out by making it 0, right? Earlier you have seen that we have not made this 0, that's why it was toggling. The third output pin was toggling, right? Now we will build. Now come over here, come to properties, C++ build, click on setting, then click on MCU setting and post build output. Tick this box, convert to Intel hex file, and click apply and close. Okay, once you do that, the hex file will be generated in the debug folder. Now come over here. So see, in the Bluetooth communication, right, there you will find the 3 settings: core, debug and drivers. Now come to debug, and here you will see the latest hex file. Okay. So latest hex file means, see, it is 6:33 and 6:34 p.m. The date is same. Okay, now click on OK. So first thing, whenever you are running the program or starting the program, STMetaTronics will be displayed over the UART, right? Now if I press first button, A is sent. If I press second button, B is sent. If I press third button, C is sent. Correct? Now if I enter capital X, right, output is on. If I again enter X, output is off. If I enter Y, output is on. If I enter Z, output is on. Third output is on. If I enter Y again, second output is off. If I enter Z again, third output is off. So this is fairly simple program. So why we have taken these two Bluetooth modules? So what you can do is you can make this project, okay, controller side of part, and you can send the Bluetooth commands from your mobile app, right? So you can have the serial communication mobile app or any local app which contains the Bluetooth communication. So that you can use and send the command from your mobile. Your controller will receive those commands and will take the action according to it. So that's it for this video. If you like my explanation, give the video a like, share with your friends, and subscribe to our channel. Thanks for watching this video. We'll see you in the next video.